Hello, Sanbonani, Sanwona. Yes, I am greeting in Zulu because Duolingo Zulu course is the sole reason why I haven't made a video in ages. Anyway, I'm also trying this new approach where I bulk record and then one day I'm just gonna poof dump the whole series on you. Anyway, so today we are inside IEB May 2024 paper 2, and we are looking at question 6c today. Okay, let's go. If sine of A is 2/3 and cos of A is smaller than 0, i.e. it is negative, determine without using a calculator, because of course you could use a calculator to solve for A, right? So no calculators allowed. What is the value of tan of negative A? Okay, so immediately what comes to mind for me is the sine ratio of this angle is positive. So if I think about cast, then there are two possibilities. It's either this angle is which cast is this one? My goodness. Ooh. Delete from your brain. Okay, right. So either this angle is in quadrant 1 or it's in quadrant 2. The second piece of information is that cos of A is negative, and cos is negative for angles in this quadrant and in this quadrant. So this quadrant is where both conditions are met. So we now know that our angle A is in quadrant 2. Okay, so right. Then we need to find tan of negative A. And of course, because the information we're given is not about negative A, we're given information about A. So you want to then rewrite this ratio so that it's a ratio of A, not a ratio of negative A. So our reduction formulae tell us that tan of A is the same as negative tan A, right? So if you imagine that, it's always easier to remember your reduction formula if you imagine that A is acute, even though in this case we know that A is definitely not acute because it lives in here somewhere, right? But just imagining that it's an acute angle helps us remember better. But the idea is that reduction formulae work for whatever angle. It doesn't have to always be an acute angle. Anyway, well, so if A, for argument's sake, lived in here, then negative A would live over here, right? And we know that tan is positive here, but tan is negative here. So that's how we know that, okay, tan of negative A is equal to minus tan A. So even if you think about where A actually is, right? So we said A is an angle that potentially looks, something like this. Of course, it could look like that, or it could be that plus a revolution. I don't know what I'm trying to say. That plus a revolution, right? So that would be another possibility for A, and you could add as many revolutions as you want to. You could go the other way with the revolutions, all of those would be possibilities for A. Okay, what am I doing? Okay, anyway, so simple case, let's say that A looks something like that. So then we know that minus A will go in the opposite direction, so it'll look something like this, right? And so we can see that all things being considered, so if you literally took an arm of the same length and you drew the angle negative A, so this would be the same length as well. We've chosen it that way. And you can also kind of see visually that the x and y coordinates will be the same, except the y coordinates will be negated versions of each other. So if the y coordinate here is 1, this one will be minus 1. And so the tan ratio of this angle, which is our A, would be negative, right? Because you have a positive y divided by a negative x, so you end up with a negative tan ratio for A. But what happens with the tan ratio of minus A? Well, because this will be some coordinate minus x and a minus y, right? When you divide these two, you're going to end up with the positive version of the fraction that we got over here. I hope I'm making sense. So if this was so this would be minus x and a positive y, so then tan of a would be minus y over x, right? And tan of negative a would be minus y over minus x, which is just the same as y over x. And so indeed the tan ratio of this guy is the negated version of tan a, right? So basically this is true. Right, even though our a is not acute, but we use acute angles to help us remember the ratios because it's in the name, they are acute. Anyway, so forward we go. We now need to use the information we're given to figure out tan a. So again, we're gonna draw the situation. So the situation is that a is maybe an angle like this. Like I said, could also be this angle plus a couple of revolutions or minus a couple of revolutions, doesn't really matter. So we know that sine a, the sine ratio, is given by, hey, what is it given by? Y over r. Yes, y over r. So we can treat this ratio as this is the y coordinate and this is the r. Bear in mind, you could look at it as 4 over 6, you could look at it as 6 over 9. The point of the sine ratio is it is saying for this angle, the ratio between the y coordinate and the length of this arm will always be 2 over 3. So if you stretch it a bit more, then this y coordinate is also going to change accordingly, or if you shrink it, then this y coordinate is also going to change accordingly. Anyway, so the easiest is always to just take the ratio as it is. Okay, not always, let me not say always. In this case, the numbers are nice enough to just use the ratio we're given. So we can then say when the length of this arm is 3, we know that the y coordinate is 2. Okay, so now because we want tan, we need to figure out the x coordinate, right? So of course we use Pythagoras. Okay, so we know that the length of this side is 2 units and this one is a question mark. So 2 squared, using a pencil, I'm not, 2 squared plus the unknown squared is equal to 3 squared. That's because Pythagoras said so. Okay, so that's 4 plus something squared is equal to 9, meaning that the something squared is 5, right? And ordinarily there would be possibly 2. Okay, no, because we're dealing with a length, sorry, I was about to speak nonsense. Because we're dealing with a length, we know that we're only looking at the positive square root, we don't care about the negative square root. But yes, it is always important to think about whether both answers are appropriate for the context where you're solving the equation. So we now know that, okay, the length of this other side is square root of 5. So what does that tell us about the x coordinate? It tells us that the x coordinate is minus square root 5. Yo, that is horrible. Okay, let me just write it nice and big over here and then shrink it. Don't you just wish you could write exams like this? Yo, my goodness, so much fun. Okay, right, so now we can say therefore tan of minus a, which is the same as minus tan of the angle we're dealing with here, minus tan a, will be equal to minus the y coordinate, which is 2, over the x coordinate. Yo, I'm running out of space. Oh, that's a lot. Okay, I don't want to make a whole new page. These are strong mathematics. These are strong. So this will be 2 over root 5. And I think they will accept an answer like that. But if you want to rationalize the denominator, you'll times top and bottom with root 5. And at the bottom, you'll have 5. Okay, so that's the first one done and dusted. Awesome. Next one. So same question, but now we're looking at sine of a plus 30. So we are given information about sine a, and now we're looking for the ratio of a ratio related to a plus 30. So what we can then do is we can use the compound angle identity, right? We know that sine of a plus b is equal to sine a cos b plus cos a sine b, right? Ooh, 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 ooh. So what this means for us is this ratio that we are being asked to evaluate is the same as sine a cos 30 plus cos a sine 30. Okay, and we're not allowed to use a calculator, so you need to know your special angles ratios. So for 30 degrees, I just find it always useful to remember that sine 30 is a half, because you can work out everything else from there, right? So if you just remember that, then you can kind of draw a little triangle for yourself where you have an angle 30, and you know that the opposite over the hypotenuse, the ratio is 1 to 2. And then you can use your Pythag to work out this side, which would be root 3. So then now you know that cosine of 30 is adjacent over hypotenuse. So, right, anyway, sine A we've been given is 2/3, and cos 30 is root 3 over 2. Nice. Then cos A we don't immediately know, but we can work it out from our previous calculation. Cos A is given by the x-coordinate divided by the radius. So this will be negative root 5 over 3. Negative root 5 over 3. And then sine 30 is a half. Right, and I do have a video about ways that you can remember the special angles ratios. If I'm feeling myself, I will link it somewhere at this point of the video. Okay, so now without a calculator we are calculating this. I don't think they actually really care at this point if you use a calculator, don't quote me. But anyway, it's good to flex your arithmetic abilities now and again. This term is negative, so it's the same as minusing. So now we have root 5 over 6. So our common denominator would be 6 here, and then this fraction we'd need to times top and bottom with 2, so times 2 over 2. So then we have 2 root 3 minus root 5 over 6 as our answer. And of course, at the end of the day, you can use your beautiful calculator to just double check your answer. So I mean, obviously there's a lot of solutions for this equation, well, with these conditions, because like I said before, it could be this obtuse angle, or this obtuse angle plus a revolution, or this obtuse angle plus 2 revolutions, or this obtuse angle minus a revolution. Hey, where would the minus revolution go? Yeah, so it would be this obtuse angle minus a revolution. Yeah, anyway, there are lots of solutions, but we can just pick one, because you know, we're not full on solving this thing. We're just you know, trying to see if our things are aligning with the heavens. So inverse of sine of 2/3 is 41,81. So that would be the angle in this quadrant that, you know, kind of mirrors this point. So then that means our obtuse angle would be this. So I'm more than happy to use this as our A. So I'm going to store that fittingly in a variable called A. Okay, so now the first thing is we want to know what is the value of tan of negative A, to which we have said we think the answer is 2 times the square root of 5 over 5. So let's see. Tan of negative a is 2 root 5 over 5. Okay, and then the next one we needed to calculate was sine of a plus 30. So sine of a plus 30, and that is a decimal. Why are you not giving me the what? What's going on now? Okay, so okay, that's the decimal we get. Let's see what this answer that we got evaluates to. Okay, 2 root 3 minus root 5 divided by 6. I sound like a wounded whale, so let's stop right there. So that's that on that. Yeah, I think I'm actually very lazy I'm gonna be lazy to try and find the point where it talked about special angles. So I am going to go right ahead and put a link to the video that I made about special angles. I think there's two actually. I'll put it here. Thank you for tuning in, and yeah, let's catch each other another time.